This is an example of a car loan amortization. Of course, this works for any kind of loans, including home mortgages. So here we have, let's say we're borrowing $8,000 to buy a car. Now, maybe the car costs $12,000, but we put $4,000 down. So the only thing we have to borrow is $8,000. And my plan is just to pay off $500 a month at an interest rate of 5.5% APR, compounded monthly interest rate. So this type of thing is not usually what goes on when you borrow money from a bank to buy a car. But let's just say we use this $500. It's not anything specific. We don't know how long this loan is going to go, in other words. So I like starting off with payment 0. And the only reason I like doing that is because we're not making any payments. We're just getting the loan that day. We're not going to pay any interest. This leftover column, I'll explain as we get there. But we do have a balance. And I like calling the balance here because I know I need to use it in an interest calculation in the first payment. And I'd rather call it from this position, E8, than constantly pulling it from C3. It just makes our formula building a little bit easier, I think. So this cell, we're going to do the counting thing. So we're going to call the cell above it and add 1 to it. Finally, we're going to be paying something, and we're going to be paying, well, this amount here. We might change later on. And in this example, it will. Then we have to call in the interest. Now, the interest is PRT, principal times interest rate times time. So I'm going to say equals principal, and that's why I want the 8,000 there, because that'll be where the principal is for each one of these calculations in that column. I'm going to multiply by the interest rate. That's never going to change. So I want to hold it fixed, F4. And then I want to multiply it by the time. Well, each time we make a payment, we have to pay 1 month of interest. So that's 1 divided by 12. All right, hit equals. So we owe the bank $36.67 for borrowing this money for 1 month. So when we make a payment of $500, the bank's going to take 36 of that away automatically. So that's what I consider my what's left over column. So it's going to be your payment minus the interest you have to give the bank. So technically, you're not reducing your loan by $500. You're only reducing your loan by $463. So this one is going to be your previous balance minus your leftover column. Your payment minus your interest. And then this will be your new balance for the loan. So after 1 month of payments, you have reduced your loan by a little bit less than $500. All right, so I'm going to continue that on for one more. I'll drag this formula down. It works. This one's not going to work because it's calling that 500. So another way of changing in this cell, which I like doing, is saying equals the one above it. And the reason I like doing that is maybe later in the loan you want to add $25 to your loan. So if you just change one of the cells up by 25, the ones below it will change, but the ones above it won't. So it just gives a little more flexibility in a formula instead of calling that 500 up there all the time. All right, this one should be exactly the same as the one above it. It should be, let's look at it, E9, which is the balance previously, times the interest rate, C5 in this case, and then technically times 1 month out of 12. So that works out pretty fine. What's left over should work also. This number should be 500 minus 3454, which it is. And I can double check that. It's calling the right two numbers. And then this one should also work because it's just the difference between the balance and what's left over. And you can see that there. E9 minus D10. All right, so our formula is all set to go down. So I'm going to select all the way across and drag down. I'm only going to go down a certain number. I don't know when this is going to peter out. All right, so there's 20 payments. Now the problem is when we get down to the 20 payments, the balance is negative. So what you do is you go back to your last positive number, which is this one. So we're going to make 16 payments of $500 and then one payment of $326.30. plus the one more month of interest, $1.50. And then we'll have the loan all paid off. So I can change this number here to 326.30, and you'll see that there's $1.50 left over. So we're going to have to change that number to 327.80. 27.80 cents. And there we have a zero balance. Most loans, when you get near the end, they don't exactly get down to zero because you're rounding numbers. And also, this is not a precise method. This was just an agreement between me and somebody else, maybe, of paying off this loan. All right, I already have a problem with these numbers. The ones at the bottom, for some reason, didn't switch to dollars, so I'm going to force the issue. There we go. All right, so we would finish this loan in 17 payments and be done with it. Since I got down to zero there, I'm going to delete these cells. And what I want to look at is the interest. So this would be equal the sum of all the interest payments here, starting from the bottom all the way to the top. So this loan's total interest was $327.80 to pay off this loan. So another way of coming up with that number, of course, is to take all your payments. Oops, I forgot to put the word sum in front of it. So frustrating. Equals the sum. And add all these up. So this number is how much you paid out in payments. And if you look at it, what's really cool is you started with $8,000 and you ended up with $8,327.80, which is exactly how much interest you paid on the loan. All right, so payments are interest plus principal. Remember that, interest plus principal. All right, so let's do this more precisely. This was just a kind of loose-ended agreement. Banks don't do that. Bank wants a specific amount of money per month so that you pay it off over a specific period of time. So one way to do that is a huge formula. The other way to do it, which is much easier, is a loan calculator to find monthly payment. Banks usually have these online. I just chose one at random. So I used this one. So here we have the loan amount, which we're borrowing $8,000. The interest rate is 5.5. And let's say the term is 36 months. So you put in 36 months, which is 3 years, and hit calculate. It does all the work for you. So if we make monthly payments of $241.57, let's make it a little bit bigger, then we'll pay off the loan after 36 months. So let me copy that. So paste $241.57 into our monthly payment. Our interest rate is already there. Our balance is already there, and if we go down, it's going to be longer than 17 months now, because we said 36 months. So let's go down to 36 months. Take this formula and start dragging it. See how far we've gone. That's 38. All right, so delete these two, and let's look back up. Something's wrong. Oh, that's right, we changed this number. Drag that down one. All right, drag that down all the way. There we go. So when we get down to the end, the 36th month, we're making our last payment, and we actually overpaid by 11 cents. And that's no big deal. They would refund it or just keep it. It's only 11 cents. So that forces this loan to go to zero exactly after 36 months. Again, we can look at how much interest we paid. So it would be the sum of the interest or the sum of your payments minus your original principal. But while we're in a spreadsheet, it's just as easy to add up the interest. Now remember, the last one we only paid like $300, $400 of interest. Now we're up to $700. It's because it's more than twice as long. We're paying more interest because we're keeping the money a little bit longer. And of course, if we went more months, 48 months, which would be 4 years of loan, we'd pay even more interest on for this car, and thus paying a lot more for the car. Now, if we add up this column, the payments, This would be how much money you paid for the car. So we originally paid for we took a loan out for $8,000. So here we're paying $8,696.52 for the car, plus any down payment that we may have made previously. So this is an amortization of a loan.